So let's get to now when you have triangles and vectors that are not 90-degree triangles. So if we have 90-degree triangles, we can obviously use SOHCAHTOA or trig ratios to work out a missing side. Okay, but now we're going to start having situations in vectors where we have triangles that are not 90 degrees. And then we're going to start using sine and cosine rule. And at this point in maths, you probably haven't learned the sine and the cosine rule. So we quickly have to teach it to you in science, and then we can apply it in this section. Okay, so you use it for non-90-degree triangles or non-right angle triangles, but they're actually so nice that oftentimes once I teach sine and cosine rule, people will just use it in any triangle, even if it's a 90-degree triangle, which is also fine. Okay, so it works for 90 and non-90-degree triangles, whereas SOHCAHTOA or trig ratios only work for 90-degree triangles. Okay, so let's start with sine rule. So this is your formula for sine rule. Okay, it's sine A over A is equal to sine B over B is equal to sine C over C. Any math formula like Pythag or trig ratios or sine rule, none of those are on a science data sheet. So you have to learn them yourself, but you're going to use them so much you'll just know them off by heart in any case, hopefully, by the end. Okay, so let's start with sine rule. Let's draw a little triangle here. So let's say that we've got this triangle. You've got a 50-degree angle here, 30 degrees here, and 12 centimeters at the bottom. And I'm looking for this side here. So your first job is to label your triangle. Okay, so let's label, and you can choose to label it however you want if they haven't given you labels. So if that's angle A, then the side opposite that angle becomes baby side A. And if this is angle B, then the side opposite that would become small b. And if this is C, then this becomes side C. Okay, so the angle always makes the side that it matches with. Now you'll notice here that you've got the side A, and you could obviously easily work out angle A. So let's work this out. So this would be 100 degrees because of angles in a triangle. And when do you use sine rule? You use sine rule when you've got a matching pair. So for example, you've got angle A and side A, or you've got angle B and side B. In this case, we've got this. Well, we didn't technically have this to begin with, but we could easily work it out. So let's write here, use sine rule when you have a matching pair. Okay, for example, side A plus angle A. Okay, for like in the example we have in front here. So we want to work out side B. Okay, so let's work that out. Let's not stress too much about the SI units and turning everything into meters now. Let's just learn the method of actually solving the triangle. So you'll never write all three of these ratios down. You'll pick, for example, just this part and just write that down, or you'll pick the second part, whatever is applicable to your sketch. So in our case, because we have A and side A, we're going to start with sine A over A is equal to sine B over B. Okay, oftentimes people will say, well, if you want the side, then you must actually write the side at the top and the angle at the bottom. It makes no difference. It's not going to affect the way you solve this at all. You're welcome to do that, but it makes no difference to your calculation. So sine A, okay, my angle, so sine of 100 over 12 is equal to sine of 50 degrees over side B. Okay, then the way we're going to solve this, okay, if you have fractions and you're multiplying them, maybe let's just go back a second, okay, just in case that's something that you might struggle with. Okay, if you have fractions and you're multiplying them, normally, then you just times the top with the top and the bottom with the bottom. If you have fractions, but there's an equals in between them, then the quick, like shortcut way to solve them is to cross multiply. So it ends up being B times sine 100 is equal to 12 times sine 50. I'm careful to write sine 50 times 12, okay, just in case people make a silly error on the calculator and they end up saying sine 50 times 12. okay, instead of sine 50 multiplied by 12. Okay, so I'll just try and avoid any little errors we can make here. Then to get b by itself, we're going to divide both sides by sine 100. Okay, so that cancels out. So therefore my side b ends up being 9,33 centimeters long. Now you always want to check if your answer makes sense. Let's go back to the sketch for a second. Okay, and put in the 9,33 centimeters. Okay, which is what we got there. So the way you check if that makes sense, we obviously don't know 100% if it's right, but if you look at this, the 50 degrees is opposite the 9,33, whereas 12 centimeters is opposite the 100 degrees. So the bigger side should be opposite the bigger angle, and the smaller side should be opposite the smaller angle. So this does make sense. So I'm thinking I'm on the right track. Okay, even though we don't know 100% always if we're right. Okay, and obviously this we can't use Pythag to work out this side here because it's not a 90-degree triangle, so don't be tempted to do that. Okay, so you use sine rule when you have a matching pair, like side A and angle A, or side B and angle B. Then let's go on to cosine rule. Okay, looks very complicated, it isn't really. Okay, your formula for cosine rule, which again is not on the data sheet. Okay, depending what you have to work out, your formula looks like this. Okay, so if you're looking for side A, then it's the other two sides, b squared plus c squared minus the same, 2bc, and then the angle is always the angle that matches the side that you were trying to work out. So similarly, if you're looking for b, it's going to be a squared plus c squared minus 2ac cos of angle b. And if you were looking for side c, it would be a squared plus b squared minus 2ab cos of C. Okay, so when do you actually use this? So let's draw a little triangle. Okay, so first of all, let's label a triangle. So let's make this A, B, and C. Opposite side, angle A is side A, opposite angle B is side B, and opposite angle C is side C. Now, you'll notice here I don't have a matching pair. I don't have A and A, for example. I don't have B and B. And I can't even do angles in a triangle and try and get that for myself. Sometimes you can. In this case, you actually can't. When that happens, okay, you actually end up having what you call an included angle. What does that mean? It means you have a side, the angle, and side. So you have the angle in between the two known sides. That's called an included angle. And then when you have an included angle, that's when you use cosine rule. So let's write that out very clearly. Okay, use cosine rule when you have an included angle. Okay, what does that mean? It means we have that side, and the angle in between the two known sides. Okay, now you could obviously label your triangle however you want. Okay, let's say that we're looking for side A here. Okay, so then my formula would go a squared. Obviously, you could have labeled this B and then this angle B, and then your formula would be b squared is equal to etc. Okay, but because I labeled it A, it's going to be a squared is equal to b squared plus c squared minus 2bc cos A. Okay, so then my b is 7, my c is 9. Okay, then you plug this into your calculator. Just remember your calculator needs to be in degrees, which means that the top row of your calculator needs to be a D there, okay, as opposed to a R for radians or G for gradians. Okay, you might just by accident have put it in a different mode, or if you do AP Maths, then you might have it in a different mode. Okay, then if you do all of this, remember if you actually want to get A at the end of the day, you need to square root all of that. And once you do that, pause the video for a second, work it out, because the last reason you ever want to lose marks in an exam is because of calculator mistakes. You should get 12.32 meters as your final answer there. Okay, so to recap, if you want to use sine rule, you need to have a matching pair. So you need to have side A and matching angle A, or B and B, whichever one. And if you want to use cosine rule, you need to have an included angle. In other words, a known angle between two known sides. Now that you know sine and cosine rule, you are welcome to use it in 90-degree triangles. Like I said, oftentimes when I've taught this, people will now use this instead of trig ratios.